Now we'll talk about principle of reversibility of light. It is also one of the phenomena associated with light, which says that light travels from one optical medium to another optical medium. The light will be bending towards the normal or away from normal. We have already studied. But at any point in the path of a ray of light, if its path is reversed, so whatever path light has followed, it will trace the same path. It will retrace the same path. So the principle of reversibility of light states that when path of a ray of light is reversed at any point in the medium, remember, when path of a ray of light is reversed at any point in the medium, that light will always retrace the same path. मीन्स वो जिस पाथ से आया है वो इसी पाथ से वापस जाएगा. So the principle of reversibility of light states that when path of a ray of light is reversed at any point in the medium, it retraces the same path. So what I have done here, I have taken a path PQR which is traveling from optical medium 1 to optical medium 2. This is having refractive index mu1, refractive index mu2. That means we can say the light is traveling from rarer to denser because it is bending towards the normal. Okay. So for the path I am talking about PQR, we have to derive a condition. For path PQR, what is the incident ray? Come on, tell me. For path PQR, what is the incident ray? Incident ray will be PQ, correct? And what will be the refracted ray? The refracted ray will be QR. So for path PQR, incident ray will be PQ, refracted ray will be QR. And this PQR is traveling from mu1 to mu2, which helps us to write the Snell's law, right? And what is the angle of incidence? Remember, angle of incidence is the angle made by incident ray with respect to normal. So what is the incident ray over here? PQ. What is the angle made by PQ with normal? Come on, tell me. I. So it will be I. The angle made by the refracted ray QR with normal will be R. So if I write Snell's law over here, it can be given as, come on, tell me, mu2 of 1, because the light is traveling from 1 to 2. We will simply say, sir, it is sin I, sine of the angle of incidence to the sine of the angle of refraction, right? So what I am doing over here, I am just placing a mirror, and we make sure that the ray QR falls normal to mirror. So you must be aware that if on a reflecting surface, if a ray strikes normally, it retraces the path. You must be aware of this concept. So what I am doing, I am placing a plane mirror normal to the direction. Now we will say this path will retrace. So now the path will be like RQ to QP. So I am talking about the next path RQP, RQP. So for path RQP, what will be the incident ray? Come on, tell me. RQ. What will be the refracted ray? Come on, tell me. QP. The angle made by incident ray with normal is called as angle of incidence. So don't go with the notation, go by the definition. Sir, RQ is the incident ray and angle made by RQ over here is R. So angle of incidence will be R and angle made by refracted ray QP will be I, and light is traveling now from mu2 to mu1. So if I talk about Snell's law, the Snell's law will be written as refractive index of 1 with respect to 2 because it is traveling from 2 to 1. This can be given by sine of the angle of incidence to the sine of the angle of refraction. But what is the angle of incidence over here? I. What is the angle of refraction? Angle of incidence R. What is the angle of refraction? I. Got it? I can take the reciprocal of it. I can sin R by sin I का value I can write it 1 by sin I by sin R. Numerically it is correct. 2 by 3 can be numerically written as 1 upon 3 by 2. So sin R by sin I wrote it 1 by sin I by sin R. But what is sin I by sin R? Mu2 of 1. So mu1 of 2 का value will be 1 upon, come on tell me, mu2 का 1. That means that value will give you mu2 into 1. Mu2 of 1 is nothing but, come on tell me, mu1 of 2, or I can simply write the product of refractive index of 2 with respect to 1 and the refractive index of 1 with respect to 2 will always give you 1. This is the condition for the principle of reversibility of light. Thank you.